Okay, so one of my viewers recently said, Tom, you talk about backtesting and vectorized backtesting, and that's all good and well. So, how can I incorporate stop loss and profit takes into my vectorized backtesting? And I thought, oh, nothing easier than that. We just go and I'll just show you, I'll do it. Now, in loop backtest, that's really simple. You just add an entry condition or an exit condition with this specific condition, and that's it. Now, when I actually started to build a vectorized backtest, I quickly realized, whoa, wait a minute, this is actually not so easy. It's fairly straightforward to implement a lot of trading strategies as a vectorized backtest with a little bit of math complexity. But when it comes to stop losses or profit takes, it's a bit more tricky. Why? Because the trading signal isn't dependent on something that is continuous, but it's dependent on when a trade was entered. So it somehow needs to know, or the exit needs to know, oh, at what point was the trade entered. And again, that's easy to do if we just loop over our array or whatever, and then we identify this and do it. Now, the downside of this is loops take quite long, whereas vectorized backtests are blistering fast. And I show in some of the videos in my workshops, where you find a link below, that vectorized backtests can be 2 orders of magnitude or over 100 times faster than loop backtests. And so for parameter optimization and many other purposes, they are fantastic, because if your optimization runs for a few minutes rather than a few days, then that's definitely a big bonus. So let's dive into it. And the strategy I choose today is purely for demonstration. It's not for you to trade. Hopefully you're aware of that. And it's basically what I call the hello world of all algorithmic trading strategies. It's the moving average crossover. So we basically got a slow and a fast moving average, and when they cross one way, you go long, and when they cross the other way, that means one is over the other, we go short. And what we do today is we just use the long only version of it, just to make it a bit more interesting. And the long only version is basically just cutting out the shorts. The reason for this is because equities are notoriously difficult to trade on the short side from an algorithmic perspective, simply because they have an asymmetric return profile, which means companies or equities generally produce value for the shareholders as they go along. They're not a zero-sum game, so they become overall more expensive. And so usually the returns are skewed to the right-hand side. And that's why it's sometimes a good idea to go long only. Now again, there's advantages and disadvantages. Obviously if you go long only, you can't apply as much leverage and so on. So that is stuff that can be discussed in other videos. Today we're just looking at the moving average crossover. And again, the other thing that we do is we chop the moving average crossover with a profit take and a stop loss. Now, one of the reasons why I have never really talked about this for vectorized backtesting is because I don't use profit takes and stop losses very often, and I never really had the need to apply them to a vectorized backtest. But obviously there's other people that do, and so for me it was quite an intellectual challenge to look into it anyway. And then if you have strategies that use profit takes and stop losses, or you think about it, this is a great way of doing it. Now again, it's going to be a little bit involved from the programming and mathematics perspective, but I hope you really enjoy this video. Okay, so I do this in a Google Colab environment using a Jupyter notebook. And the good thing is you don't actually need to have any Python installed on your computer. You can just run it in the Google Colab. And sometimes you have to install a few extra packages. But in general, it's a really handy thing to do, and anyone can use it, and it's quite repeatable. Any two people who use the same Google Colab, they can have the same environment, which is fantastic. Now, the first thing I do is I install yFinance, because this is where we get our market data from. It's the yFinance package, which is not part of the standard install of Google Colab. And once we've done this, so I run this, so it just starts to install it. And then once we've done this, we import yFinance as well as NumPy, Pandas, Pylab, Datetime, and copy, which are just little things that we need further down the track. And then once we have this, we can just go YF, Y Finance, to download. In this case, I just download SPY and APL. You can just load as many stocks as you want, but for simplicity's sake, I use two. One is a bit tricky because with one, sometimes we can't really get the power of the backtest because it changes things a little bit. So two is just perfect. And once we have them, we just take the adjusted close prices because that's all we need for today. Our strategy only runs on adjusted close prices. There's obviously other indicators that run differently, but today, you know, that's good enough for us. So here we download those two and we get a pandas data frame. Wonderful. Now let's build the strategy. And so because it's a moving average crossover, we have to generate moving averages. So we could use TALib, the technical analysis library, for that as a package. And again, if anyone's interested of how to use it or how to use it in Google Colab, I've got some videos on YouTube. I've also got a course on backtesting, which you can find a link below, that talks about this in great detail. Now today for moving averages, we just use pandas. And what we do is just adjust it dot rolling. Let's just take a window of 20 and dot mean, so it's the rolling mean. And then we subtract another longer moving average from that, or slower moving average as you will, dot mean. So it's a 200-day moving average. So 20-day moving average minus 200-day. And then what we also want is, rather than the numerical values of those two moving averages going up and down, we just want the sign. So we say, well, if it's +1, we're in a long. If it's -1, we're in a short. So we just go mp.sign. And let's just plot this for a moment to get an idea. So you can see here, it oscillates between +1 and -1, back and forth, long, short, long, short. Orange is SPY, blue is Apple. Okay, so I said we want to do this long only, and there's a trick to do this. We just shift our signals up, so the -1 short signals become 0, so there's nothing happening. But the +1 signals become 2, the long signals, so we need to bring them back down to 1 so we can make a proper calculation. And so what we do is we add 1 to the series and then divide it by 2. So let's just do this. So we go +1 and divide it by 2, and then we put some brackets around it so we can plot it. And there you go, you see here. So this is tricks of vectorized programming. You need to just think a little bit about how you arrange the vectors for your signals and for your returns in order to get the right results. And so now here you can see we go from 0 to +1, and then, you know, 0 is basically when we have no trades on, +1 is when we have our longs. Okay, so let's just give this a name and call it short SG for signal and run it. Now the next thing we do is we produce our strategy returns. We call them reds, and they're just adjusted.pct percentage change. So that's a handy Python, a handy pandas function for percentage changes, which gives us the returns out of the box. And then we need to create our strategy returns. So the returns that we use in our strategy, we call them strategy reds equals, and then of course we get our returns. But what we need to do is we need to shift our returns 1 to the left, because when we have our signal, we don't want to, and we have our returns, the return actually is the return from the previous period, but we want a return from the next period. So what we need to do is shift it to the left. So we do reds.shift -1, okay, and then we multiply that by the signal. And so let's just plot it. So plotting is really crucial when you do vectorized programming. You just really need to see what happens, and here you see all these individual individual islands here, they are our trades effectively, and when we have a flat line, there's just no trade, or we would have been short, but now that we go long only, there's no trade. So let's just calculate the P&Ls for this. So we just take the cumulative sum and we plot it. Okay, there we go. This is the performance of the strategy. Now, why do I take cumulative sum? Some of you might argue we should use cumulative products. Well, cumulative products are basically, it means that we reinvest all our proceeds from the strategy again and again. And that's obviously how it should be done. But what I found is that when you use cumulative sum, where basically always assume you have the same cash base. So whenever you make, let's say, when you start with $100,000, and whenever you make $1,000, you take it out, or whenever you lose $1,000, let's say you're at 99, you take $1,000 and put it back in. And what this does is it actually gives a bit more of a realistic view of the P&Ls. So for example, if we did a compounded P&L, so we would do this 1 plus, so we add 1 to the returns. This is what we need to do. And we see this. So yeah, this looks pretty exorbitant in terms of your returns and so on. And yeah, I mean, yes, if you had invested it like this, it would probably have given you these results. But for the sake of a backtest, it's just simply more realistic to use cumulative sums, in my opinion. So let's just stick with that, and we keep our philosophy discussions maybe for a meetup or something where we can discuss whether that's right or not. So we can call this P&L equals strategy reds.cumulative sum, and here we go. So now we've produced our vectorized strategy. So vectorized strategy is the easy part. Now it comes the difficult part. We actually need to somehow implement the stop loss and profit take. And as I go along, you will see it starts to make sense how this works. Now, the first thing that we need to do is we need to somehow produce our entry and exit signals as individual signals. So whenever we have an entry, remember our trading signal goes from 0 to 1. What we want is our entry only, because what we then have is we have our entry only, and then when it goes from 1 to 0, we have our exit only. And then what we can do is we can actually insert the exits from the profit takes and stop loss in between, because we exit them usually earlier than, or always earlier than the original or natural exit, and then we effectively combine them, and then we forward fill the signal further, and this is the way we can then actually implement entries and exits. One of the issues is that effectively the stop loss and profit take signals depend on the entries, so we can't just extract them from the time series as individually, and so that is actually what makes this whole thing a little bit more tricky. Okay, so let's do this. So I call this reset, and you will see later on why reset is a good name, and it's basically the difference of our signal. So it's basically when it goes up, we go in upward edge, we go in entry, it's +1, and then we get an exit, it's -1. And so we need to we can put a sign around that, and then we know it's perfect. And so what we do is we go reset.plot, and here you can see here we've got an entry signal, then exit, entry, exit. So in a moving average crossover strategy, an entry always follows an exit, so there's always this nice symmetry, entry, exit. So there's not going to be one entry and 3 exits or something like this. This is just how this works when we do it in a vectorized fashion. Now the next thing we want to do is this. We want to go, okay, here's the entry, and this is our entry price from the P&L curve. And so when we know exactly what that price is at what point, what we can then do is we can take our P&L curve and subtract those prices from each other. And what that does is it brings each trade beginning down to the zero line and then starts going up and up and up. And then when the trade finishes, we just drop back down to the zero line again. And that way we can actually see what the individual profits are within each of the trades. Okay, so let's just give this a try. And the first thing we need to do is produce this variable that gives us the entry price. And so what we do here is we got our P&L and our reset variable, but we want the resets where reset equals 1, so we only want the entries, right? And when that happens and we run it, we see that there is actually a lot of NANs in here. So there's a few numbers in here, but a lot of NANs. And so what we need to do in order to get rid of that is do an fill. So what this does is effectively it takes the trade value at the entry and just carries it forward all the way to when the next trade starts. And let's just have a look at what this looks like. Okay, so basically takes the trade value, carries it forward, and then here's the next trade starting and carries it forward. Obviously what then happens is we've got a trade here happening in between. And so what we can do now is we can actually take our P&Ls or our entries and subtract them from the P&Ls, and then multiply this with the returns, and then we get this curve you will see in a moment that gives us that characteristic trade shape where we see the profits of each individual trade. So let's just give this a go. So we go P&Ls, P&L, sort of minus entries, and then we multiply this with the trading signals, because we need to effectively know where where they are. So let's just call this trade P&Ls, and let's just plot it, and then we can see what this looks like. Plot. So here we go. So let's just make this a little bit bigger. Fig size equals 10.7. Okay, and so here you can see that we enter a trade at the zero line, the trade makes us some money, and then at the end of the trade we drop back to the zero line. Here you see the same, so that's just a continuous thing. We go in, the trade makes some money, drops back, but then of course we have losing trades as well here. So there can be quite a lot of losing trades sometimes. And what you can also see is, because of this really long moving average, 200 days minus to 20 days is pretty close to the actual P&L curve. 200 days is a long-term moving average, so we stay in those trades sometimes for quite a long time, and hence some of these trades generate fairly substantial profits. That's just the nature of it. Specifically, as you can see here for Apple, for SPY, it's not quite so big. So this is basically what we want. And now what we say is, well, let's just assume we have a profit take at 0.5. What we can then do is we can chop those curves at 0.5. Now there's a problem. So and we'll see how where the problem is. So let's just plot this against some after we do some chopping. So we go trade P&Ls, and then we just go trade P&Ls larger than 0.5, for example, and then we plot that. Oh yeah. Oh, okay. So Actually, this is not so good. So let's just do it for Apple, AAPL. So dot AAPL. All right. And so here, what you can see is this. Basically, anything above 0.5 will look orange, and we chop this. And there's a big problem here, and you can see this here. So if we were just to say, oh, okay, whenever we are above the line, we say, okay, we got an exit, so we get a -1. And this is good and well, for example, for here, because when we exit the trade, we are well and truly above our stop loss. But this is not true, for example, here. We just, sorry, our profit take. We're just barely hitting the profit take, but then it comes back down again. So it's actually not -1 anymore. And in this case, and so you have to think in a vectorized way. When this happens, when it goes up and it comes down, suddenly our vector means, oh, we exited the trade, but suddenly we're back into a trade. So if we take one vector and multiply it with another vector, just purely based on what you see there on the screen, then we get a lot of errors. And what we actually need to do is we need to say, well, as soon as we hit this moment here, we get a signal, and then what we need to do is we need to then take this exit signal, like the -1, and forward fill it, carry it all the way to the end until we effectively get the next positive upward trade. So that way we can effectively chop the trade right where it is, and so it's basically then not ending at its natural end when the moving average crosses, but before. So what we're basically doing is we generate a new set of exit signals, and we overlay those exit signals to the original trading signal, and that way we can then combine stop losses and profit takes with the original trading strategy. All right, now in order to do this, we need to create a new series, and I call it chopped P&Ls, for example. And chopped P&Ls is just simply a copy of our trade P&Ls. So the reason why I use copy here is I don't want chopped P&Ls to simply be a pointer to trade P&Ls, which is what Python usually does when you just use the equal sign or the assignment operator, and then it actually modifies trade P&Ls rather than the one I wanted. So in order to avoid this, we better give it we better copy it into a new variable, and that really helps us. And then of course, one thing that I need to do also is I need to produce first the entry signals that we want. So remember, we already had the entry prices up there. So this is what we used. I call it entries. This is what we used here as a subtraction. But actually, we need the entry signals as well, that we can then take the exit signals and we overlay them. So that's just really simple. We just go signal.div, and let's just plot this just so you see it again. So here we've seen this before, +1 for entry, -1 for exit. There's always one entry for one exit. That's just how it is. Okay, now comes the tricky part. We actually need to produce the signals that give us our earlier exits, and that's probably the most tricky part of this whole exercise. Okay, so let's do this step by step, and I hope you can follow me along. If you have any difficulties following me along, it's basically just one line, but it's a big line. If you have difficulties following me along, then just revisit it a few times and maybe do it yourself, maybe plot it out, and after a while it becomes pretty clear how it works. So let's just start with the chopped P&Ls. Chopped P&Ls, and we chop them. Chop P&Ls, and we chop them at 0.5, so this is our profit take. Okay, so when we run this, we will see again we have quite a lot of NANs in here, and the first thing we want to do is we want to fill those NANs with zeros, because if we don't do this, what you can see is this. You just see those jumps up and down, and that's not so good. Now, before we fill them with zeros, what we want is to actually again sign them, because the signing is what we need, because we want trading signals, we don't want returns. So if we sign them, then you can see here you've got these areas with signals, and so let's just fill like all these gaps here. They are nans, so let's just do this fill NA 0, and then you can see we've got zeros, and then we've got those edges where it basically jumps up, and these are all the areas that where we are above the 0.5 profit take. So it jumps up, says 1, chop the trade here. So whenever we have an upward edge here, this is where we chop the trade, and when we have a downward edge here, this means we're dropping below, and this could be at the end of the natural trade, but this could also be before the end of the natural trade, in which case it might give us problems. And so we need to do a little bit of vectorization wizardry in order to get around this. And the first thing we should do is to effectively diff this. So once we have a diff, we say, okay, we've got our upward edges, which is when we're chopping, when we're ending the trade, and then of course it comes back down again. So every time we have this upward edge here is basically when the trades will be terminated. Okay, and then the next thing we need to do is effectively replace the zeros here with nans, and the reason why we do this is we want to then be able to forward fill these values at some point after we overlay them until the next trade starts. So we want to basically say, well, there's a +1, and then there's our exit of the trade is a -1, and so we forward fill the trade, and then when the next trade starts is another +1. And the only way we can forward fill is if we turn the zeros into nans. That's just how it is. So what we do now is start replace, and we go 0 and then mp.nan. Okay, so let's just plot this again. So as soon as, whenever we plot things, it's really useful. So you can see here we've now effectively plotted or we've replaced this with nans. And then the next thing is we need to, and we've already done this previously with this strategy, we shift it up by 1 and divide it by 2 in order to get those entry signals just individually. So let's just do this. So we go +1, put a bracket around it, and actually we need another bracket when we divide it by 2. Okay. Alright, so now it's between 0 and 1. All good. And so the final thing we need to do, or we should do, is to effectively fill those with zeros, all those in between areas. Fill NA 0. Okay, so now we've got our trading edges where it tells us, oh, here we should exit the trade. And now what we need to do is we need to combine the original signals with the new signals, and then forward fill the signals all the way. So we're basically making when we combine them, when we add them up, we're making the gaps NaNs, and then we fill them. So for example, let's just say we've got a +1, and then there is nans until the first -1 comes. So what's good then is we can forward fill the +1, and then there's the first -1, and then we might hit another -1 from the natural exit. So we might have a -1 from our profit take or from our stop loss, and then there's another -1 and another -1, but they're all going to be filled as -1s until we get to the next trade, which is +1. And so this way we can actually then get the entries and exits correct, which is great. Now one thing we need to do here is, in fact, we need to make this negative because it's our exit. Okay, so we've got this, and I just for sake of simplicity just call this give this a B, and then we don't need to plot this again. Okay, now we've effectively got two signals, our natural entries and exits and our unnatural exits. So that's really what we have, and then we need to combine this with our trade P&Ls, and we're done. Okay, so let's do this. So we give this a name, say this is the new signal, and then what we do first of all is we say A, which is our normal trade signals plus B. So these are our new trading signals. And now let's just keep plotting what we're doing here to understand it a little bit better. So we go new sg.plot, and so you can see now we combine signals, and what happens is, and this is really important to understand, we always got one entry signal because we got our long only entry, but then here you can see we often got multiple exit signals. So this is basically our natural exit, and then a few our unnatural exits, our profit takes or stop loss or whatever, and then at some point a natural exit. And so you look at this and you see it here as well. Here maybe I make this a little bit larger. So we've got one natural exit entry, a few unnatural exits. Here as well, one natural entry, some unnatural exits. And so you can see this across the board. Here, one entry and a few unnatural exits. Okay, so this is just how this works. And so now what we need to do though is we need to combine this with, or we need to make this into another signal which basically fills the gaps. So here right now we've got all these different exits, but what we need to do is, as we did previously with the strategy, we need to have a +1 entry. So we need to get a 1 for all the time we're in a trade, and then when it's -1 we're basically exiting the trade, and then we need to multiply this with our strategy returns and shifted strategy returns. So let's do this. So we're basically then saying we need to first of all replace the zeros with NaNs. So now these zeros, they're all NaNs, and this enables us to forward fill from our first -1 signal all the way to we encounter the first +1 signal again. Okay, so we replace this, and then we do a forward fill. All right, so let's just see what this looks like. Okay, so you can see now here we have entry and then exit, entry, exit, and so on. And the other thing that we can see is, and this is just the nature of how this works, we've gone from we're going from -1 to +1 again, because we've got this going up and then going in and going down, because we have a positive edge and a negative edge. So again, we just, in order to multiply this with our returns, we need to normalize it again. So we need to shift it up by 1 and then divide it by 2. So we need to do +1 and divide by 2, put 2 brackets around it. Okay, and here we go. So these are our trades now. Maybe we just do it for one instrument. Let's just say for AAPL. And then you can see here, so we enter a trade, we stay in the trade, and then we exit the trade. And that exit will be earlier often than the actual natural exit at the crossover, when we cross over into the short trade. So this is how it works, right? And one of the things perhaps we could also plot is the signals as we had them before. So we could overlay them. We could do something like sg.plot, and then you can see. So it's a bit difficult to see here, and we also need to do the AAPL just to be clear. Series object has no hold on, oops, sorry, this was the wrong one. So sg.aapl. Okay, so now we can see, actually here this is really good. So the orange ones are our chop trades and the blue ones are our original trades. So for example here you can see we entered into a trade here, and then we would have stayed in that trade quite a long time, but because we chop it at 0.5, we exit that trade earlier. Same here, we entered into the trade, stay in here up to a certain time, and then we don't stay all the way to the natural end, we chop it. Okay, so and this happens for a lot of the trades. We can see it here, we can see it here, but it doesn't happen for all the trades. So for example, this trade here, you can see it doesn't happen. Any of these trades, they're just staying the way they are in the natural way. Okay, so this is basically how this looks. So let's just get rid of this again and get rid of this and move on to the next step. The last remaining step is just simply to take the new signals and multiply them with the returns of our series, and then we can calculate the P&L from that and see what it gives us. So let's do this. So we go reds, and don't forget we need to shift them by -1 as we did before, times new SG, which is our new series, and then we run the cumulative sum as we did before and plot the whole thing and run it. So as you can see, it looks anything but impressive. You can see here we've got strategy returns, it gets chopped. Here again we make more than 50%, it gets chopped, and then we have these losses here. And of course if we chop our good trades, the losses will be much bigger, and so it's not particularly ideal. In this case here, we rarely ever get above 50%, so we can't see that so much. Now, one of the things we could do, for example, is instead of chopping at 50%, we chop it much higher, and then we can probably see that our strategy returns are very similar to the original returns, because we hardly get any profit takes. I haven't actually plotted the original returns, but let's just plot the original returns over this, which is easy enough. We just copy this, and instead of new SG, we just multiply it by SG, and there we go. Now this plots this in two separate figures. So one of the things we could of course do is, instead of this, we do a plt.plot, and then this, and we do the same here, plt.plot. And I hope I got the brackets right. Of course not. One of them is invalid syntax. So we've got this times new SG. So there's clearly one bracket missing. Let's see how this goes. Still, there is an issue. This is always happening. Yes, of course. So we need to get rid of this bracket here. Now let's just see. So we've got this. Oh, hold on. We've got this bracket. There you go. This is sometimes the way it goes. So we have this inside, cumulative sum, bracket around the plot. Okay, here we go. So you can see they're almost the same because we've used 1.5. Now if we use 0.5, you can see these ones for SPI, they're quite similar, but for AAPL we're obviously getting a much worse return profile. And this is what you often expect when you do this, when you do profit takes or stop losses. Often what you do is you really deprive yourself of the natural entries and exits, and that can often come back to bite you. I'm not saying this is always the case, but quite often it's actually an advantage to let strategies run in a more natural way. But you know, of course, I've seen good strategies as well that have profit takes and stop losses, and it really depends on what the nature of your strategy is. And here you've got some tools to implement it in a vectorized way, which is fantastic. Now, the last thing I want to do is I want to show you how long it would take to run this strategy. And for that, I need to put all the code together in one box, put some timing function around it, and then run it all in one. Okay, so now I took all the lines that I've produced higher up and put them all in one box, and I also put a start timer here and then a finish timer. So basically I just say datetime.datetime.now minus start. That gives me the runtime just of this code, and then I just plot it again just to be sure that everything works well. And now let's have a look how long this whole thing will actually run. And there we go, 20 milliseconds. So for all of those data that we produced and all of the backtest with stop loss, goes through all these functions, we can run it in 20 milliseconds, and this is starting from 1983. So all the daily data going from 1983 for 2 different stocks, and we run it in a time as short as 20 milliseconds. Now I can assure you, if you build this backtest any other way, it would run much longer than that. Would at least run 10 times faster if you use it in a loop backtest, or probably more like 20 times, slower, probably more like 20 times slower. So it's really amazing what you can do. And now you can take those P&L curves, you can do your analytics, you can calculate your Sharpe ratios, and more importantly, you can do, for example, wrap this in a function and do a parameter optimization. Now, let's just say you wanted to, instead of having a profit take of 0.5, you have a profit take of 0.2. You just change that number, run it just over 20 milliseconds, and you can get it. You can see the results. Obviously, they are not great. I didn't get this strategy to produce great results, but to demonstrate how you implement a vectorized stop loss and profit take. Now what I've actually shown you here is purely the profit take side. Now all I'm giving you now as a homework is just implement a stop loss as well. Now this is really fairly straightforward. So if you have followed me along and you understand a little bit what's going on here, all you have to do is you have to modify that line, or if you want to have a stop loss and a profit take, you just add one line here in order to produce your stop loss. So obviously it's good to learn a little bit when you went through the whole video. So have a look at your homework and make sure when you implement it, double check all that you've done by plotting it to see that it's actually doing what you're expected to do. This is really, really important. If it looks somehow even remotely wrong, or if you have any doubts of what you're seeing, you need to double and triple check to make sure it works. All right, so that's the end of this today. I really hope you enjoyed this video. If you want the code, please check out my workshop, and the link to my workshops is on the website below, and I hope to see you in the next video. Bye bye.